Hello folks, in this video we're going to put together Tic-Tac-Toe in Godot. It's a good starter project if you're new to Godot and uses the fundamentals like scenes, nodes and scripts. Before we jump into the code, let's look at how Tic-Tac-Toe will work. The game uses a 3x3 grid, so we will create a two-dimensional array that will have 3 rows of 3 values. We then take the mouse coordinates and divide them by the size of a cell, which tells us which cell in the grid was clicked on. We can then use that to update the array with the player number to record that a marker was placed there. After each turn, we check for the different win conditions like rows, columns, and diagonals. We also keep track of how many markers have been placed, because if 9 markers are placed and there's no winner, then it means the game ended in a tie. So with the game logic broken down into steps, let's open up Godot and start building this. When you first open up Godot, you're going to see this interface, and it might look a little bit overwhelming to begin with. We'll get into what all of these different things mean, but for now let's just start small. Let's begin by creating the game board. If we go into this assets folder down here, I've got a few images that I plan to use. So we've got the circle, cross, and then the grid. The grid is going to be our background image for the game. To use it, we're going to set up a scene which is going to have our game board on it. We've already got a scene started here, it's just unnamed, and at the top here we can flick between 2D and 3D settings for the scene. The game is in 2D, so let's switch over to the 2D setting. This up here refers to our scene and all the things that we can add into it. Our grid image is a sprite, or a 2D image. So we go into Other Node, and then here you can either manually look through all of these, or you can just type sprite at the top. And that's going to give us this sprite 2D. We'll create, and now we have a node called sprite 2D inside of our, for now, unsaved scene. Now we'll rename this to board. And once you've done that, go into scene and save scene, or you can use the shortcut Ctrl S. And I will just save it with the file name of board. Now you can see it's updated here, and this is now our board scene. As soon as we added this node into it, a lot of additional features appeared here. These are related specifically to this sprite 2D node that we added. And one of these things up here is a texture. So by default, a 2D sprite is going to need some kind of image to display. But we can just click and drag this grid straight onto it. And now in our 2D scene, you can see that the board has appeared. Now we have one scene loaded in. So we've got our grid set up. We've also got a circle and a cross. So we basically want to repeat the same process again and create a circle scene and a cross scene. And we will set them up in the same way. First, we'll need to create a new scene. So you go up into here and new scene, or I just usually use the shortcut Ctrl N. That takes us back to that screen that we saw previously. We have our scene here, and then we can add in different nodes. So just like before, we're going to add in a sprite 2D node. We will rename that node as cross, and we'll press Ctrl S to save the scene. Next, we drag an image over from here into our texture. And now we repeat the process again, Ctrl N, we add a node into it, which is going to be our sprite, and then we take the circle image and we put it into this texture. The other way to load it would be to go into here, load, into the assets folder, and then double click circle. We'll rename the node to circle, and then save the scene. So now we have these different scenes. We've got a circle, cross, and a board. But how do we actually tie all of that together? How do we show them all in the same place? Well, for that, we need one overall scene. That's going to be our actual game. So we go Ctrl N again, and we'll create a new scene here with a new node. Now this node doesn't have to be anything special. So we just go right up to the top and we just use a default node. This is as basic a node as you can make. And I will rename this node to main. This is going to be our main game file. We'll save the scene. And now we can begin pulling some of these other scenes into this main one. So for example, the game board we want to be able to show on the screen. Now to pull that game board through, we need to instance this scene, board, into our main scene. I'm just going to bring it over here. To bring the board over into our main scene, we click on this little chain link here. So I'll select main, click the link, and then I can choose one of these scenes to bring into it. So I'll select board, click open, and now you can see the game board has come up on top of my main scene. Additionally, the node tree over here has changed. I've got my main node, and then if I expand it, I've got the board underneath it as a child. But the board is sitting in the wrong place. So if we zoom in a little bit, this blue-purple outline here is our game window. So the first thing we want to do is actually check that the game window is the size that we want it to be. We go into our project at the top, project settings, and then window down here. So I want to resize that, and I'm going to go with 900 and 600. So it'll be 900 wide and 600 pixels tall. I deliberately chose multiples of 3 for the pixel resolution because we're going to have a 3 by 3 grid here. Next, we want to reposition this image. So let's move this scene around and kind of stick it somewhere around here. Now that's not going to be very precise. So instead, I can go into this Node 2D section here, expand the transform, and I can manually type in values for the position. So for the X coordinate, I'm going to put it 300, and the Y is going to be 300 as well. You'll have noticed there's a little space left here though, and that's going to be used later on for an additional display panel. So we'll come to that eventually, but for now, we'll just be aware of it. But how do we actually get functionality out of this? How do we make this interactive so that we can click on things and have knots and crosses appear? Well, this is where the scripts are going to come in. So we go back into our main scene here, and we need to attach a script onto it. And to do that, we click this little button here. This will create a new script. You don't need to change any of this, this is set up by default. So for this example, we'll just click create at the bottom. This creates a script for us called main.gd, and it links it to the main scene. The first line here says extends node. If you remember when we created this node to start with, this main here, if I just create another one, I picked this node here. You notice it's exactly the same. What this says is that this is going to give us the functionality of that node, and then it will allow us to create additional functionality below within the script. The first thing I want to do is look for mouse clicks. We're going to ignore these two functions here. They are created by default. We're not going to use them just yet, so we'll leave them as they are, and we'll create a new function here. To create a function, you just type func, and then the function I want is underscore input. Then we'll add brackets, and we'll put event inside it, and at the end, a colon. The reason this function has an underscore at the beginning of it is because it is already a defined function that's attached to this node. So I'm telling Godot that I want to use that function, but I want to look for specific inputs of my own. This function is going to give us events, and events are all things like mouse input, keyboard input, and so on. Now I want to look for a mouse click, so I can say here if event is input event mouse, and you notice the autocomplete brings up a whole bunch of different options because these are all default settings. So there's a whole bunch of different events, and we just need to select the right one. So I'm looking for mouse button. Basically, I'm looking for the mouse button being clicked. If that's the case, then I want to check for which mouse button has been clicked because I only want this to happen on a left click. I'll say if event dot button underscore index is equal to all caps mouse, and you notice already we've got the different options here, so I'm looking for mouse button left. Then let's just print out the position of that mouse click. We can say event dot position. If I run this again with F6 and I click somewhere on the screen, you can now see it's displaying the mouse coordinates. So every time I click and release, I get mouse coordinates. Now I'm also getting the coordinates on a release because that's also an event. I don't actually want that here. I only wanted to detect a mouse click. So we add an additional check here, which is going to be and event.pressed. If we test it again, we only get this event when I click. So when I release, I don't get anything triggering. Now we can start building on this. The first thing we need to already look out for is that although we only really want to be clicking in these cells, at the moment, we're actually able to click outside of the boundary of that board. So we're going to be able to detect clicks all the way out here. We don't want that because we don't want to be putting markers all the way out here. So we need to add a check for that to begin with. We need to know how wide this image is, and we need to make sure that we only detect this mouse click when the mouse cursor is on the inside of that width. To measure that width, we need to define a new variable. Right at the top here, just after we extend node, we'll create a variable by saying var board underscore size, and here I'm not going to be able to work out the size of it. So here I just define a variable that I can then use later. I'm going to assign it a type here. It's going to be an integer variable. But how do I actually work out the size? Well, to calculate the size of it, I can say board underscore size is equal to, and then I need to take this node here. So this board node, because it's already a child of our main node, I can access it. And the shorthand is to put a $sign and then put in the name of that node, which is board. Then I access the texture of that board, and then I pass the get underscore width method. But you notice this whole time, this line has been highlighted and I've been getting an error down here. I can't assign variables like this outside of functions. And this is where the ready function comes in. The purpose of this function is to run as soon as our main node is generated. That's basically what it says here. So as soon as the node enters the scene tree for the first time. So when we run our code and we run this game, this function is going to fire once. So this is where we kind of want to do our preparations. So I'm going to take this variable here, I'll take it out of there, and I'm going to put it inside this ready function. And I can print that out just to test it. So we'll print board underscore size. Run this again, and now you can see down here we've got 600, and that's the width of that image. So let's get rid of that, and we can actually use that now to restrict our mouse clicks only to the board. Now just before I print the event position, I'm going to add a comment. I'll put in a pound sign here and say check if mouse is on the game board. And to do that, I need to look at the position of the mouse. So I'll say if event.position, but this time I'm only looking for the x coordinate. So it's .x is less than my board size. Then I can run all the code that's underneath it. If I run this again and I start clicking, I'm detecting all these mouse clicks, but as soon as I go just outside the border, you see there's nothing happening anymore. So it only detects it as long as I'm inside the game board. Well, that's working well, but this is giving me x and y coordinates that are in the pixels. What I actually need to know is which grid element I'm clicking on. So am I clicking on this one, or this one? I need to convert these values into some kind of grid reference. To do that, first of all, I need to know how big each of those individual grids or those little squares are. Well, I already know my board size. I calculate that inside this ready function. And I know that there's 3 of them in each row and 3 in each column. So actually, straight after this, I can calculate the size of each of those cells. I'll say divide board size by 3 to get the size of individual cell. And I'm going to store this inside a new function. So before I do that, I need to define it at the top. Up here, we'll say var cell underscore size, and this is going to be another integer. So I'll pass an int, and I'll just add a little space here. Now I can use that variable. I can say cell size is equal to my board size divided by 3. And we actually know what this is going to be because we know that the board size is 600. So if I was to print the cell size, well, 600 divided by 3 is going to be 200. So I know that each of those squares is 200 wide and 200 tall. And the next thing to do, we can get rid of this cell size section here. So we've got different variables. We've got our board size as an integer, we've got our cell size, and then we have the position of our mouse click. We're going to take that position and divide it by the cell size, which will give us a new variable. So we have to go up here and define that variable. I'll do it above these other two, and I'll say var grid underscore pause. This one is going to be slightly different. It's not an integer because there's going to be 2 variables inside it. There's going to be an x grid and a y grid. So this needs to be vector 2i. So it's a vector 2, but it's an integer version. But in our case, this is just going to be a variable like this. It could be something like that, and that's going to be a vector 2. It's just that we have 2 variables that we want to store together in one variable. Now we go back into our input function, and after all of these checks are passed, so we've got 3 if statements here. After all those are done, another comment here to say convert mouse position into grid location. And this is done to assign this grid pause variable, which is our vector 2i, which is vector 2 integer. We take the event position, which is the mouse coordinate, and we divide it by the cell size. So now let's print out the grid position instead. So we'll print out grid underscore pause. Run that again, and as I click, I'm now getting a different variable here. So it's saying 0, 0, and it doesn't really matter where I click as long as it's inside that one cell. So remember the x and y coordinates of the mouse were changing wherever I clicked. But here it's just telling me we're in position 0, 0. If I move across, it's now 1, 0, 2, 0, 2, 1, and 2, 2. So each of these now has a value assigned to it, and we can click on them specifically. This brings us on to the next point, which is that we actually need to be able to store this data somewhere. So we need a grid of 3 rows and 3 columns inside of our script. And that way we can track whenever we click on something here, we can take that value, we can take this position, we can work out where in the grid we are and assign a marker to it. And that means we have to define another variable. We'll go up here to the top and we'll say var grid underscore data, and this is going to be an array. We want to generate this array as soon as our game starts. So that's when this ready function is fired. But I don't want to fill up this ready function. So what I'm going to do is create another function out of it, which is going to be called new game. So I'm going to call this new game function as soon as I start the game. So whenever we run our Godot project, it will run these lines of code and it will trigger this additional function. I'm going to scroll down and I'll define this new function underneath all the other ones. So I'll say I'll define my function here. It'll be new underscore game. And notice this time there's no underscore at the beginning of it like I had with input, process, and the others, because this is not a Godot defined function. This is one that I'm creating myself and I can call it whatever I want here. So a new game just makes sense. As soon as we start our new game, we want to assign this grid. So this variable here, this grid data, we want to actually assign it and create something from it. Say grid underscore data, we'll say it's equal to, and an array is going to be defined by square brackets. So we'll open and close these square brackets. So that there is our array. Now our grid consists of a row of 3, and there's going to be 3 of those rows. To start with, we want each of those to have a value of 0. That is going to just mean that there's nothing there. So there's no marker currently there. So if I put 0, 0, and 0, this gives me one row of corresponding grid. And that means that there's no markers in that row. But I need 3 rows. So I need this repeated 3 times. That means I actually need to make an array that contains these arrays. So it's called a 2-dimensional array. So I open another set of brackets at the beginning and then close it at the end. So now inside my outer set of brackets, which is my parent array, I'm going to have these little rows inside of it. To separate them, I just add a comma. And then I'll just copy this across because I need to replicate this 2 more times. And now I have 3 rows of 3. It doesn't look very pretty here though. So what I'm going to do is space them out over 3 different lines. And if I just keep hitting enter, then it doesn't matter that my starting square brackets and my closing square brackets aren't on the same lines as each other. This will still run and it allows me to display the information a little bit better. So now we can actually visually see that this corresponds to our 3x3 grid. Now that we have this grid defined, when we click the mouse inside this input function, we can assign a value into one of these grid points. So we'll use this grid position variable. I'm not going to print it out anymore. And instead, we can update our grid data array. To update an array, we actually access it in the same way using square brackets. So I could, for example, say 0 in here and assign something to that. That's going to say go to index 0, which is going to be the first row. If I wanted to access an element inside that row, for example, this one here, I would need to add a second square bracket. So now 0, 0 is going to say, okay, go to the first element because the index in an array starts at 0, which is this row. And then inside that row, go to the first element, index 0, which is this here. But I don't want to manually type these in. Instead, I want to use my grid position, which is going to be determined by where I've clicked the mouse. So it's grid position and it's the Y coordinate. Then it's grid position, X coordinate. Why is it in this order? Well, Y is our up and down. That's our vertical axis. So that's going to select one of these rows up and down. And X is left and right. So once we've selected a row, then we move left and right along it. We can then assign a value into this. So we can just say for now, change that to a 1. And once that's done, let's print our grid data. So let's run this. And if we click up here, you can now see it's not displayed in the same way as I had it in here. It's not displayed in a nice table anymore, but you can still see what's happened. In the first row on the very far right, we've put in a 1 because that's where I clicked. So if I click down in the bottom left here, that's going to change this number here. It's the third row, so it's the third one of these arrays, and it's the first value inside it because it's the first cell. But we don't want to manually assign it to just 1 every time, because that's always going to put one type of marker in that box. We actually want this to be changing depending on which player is playing. We go back up to the top, and we're going to define a new variable here, which is going to be player, and that is going to be another integer. Then inside our new game function, before we even create the grid data, we will say that player is equal to 1. So far, nothing's going to be any different, but we need to change this here. So now, instead of assigning a hard value of 1 into the grid data, we assign the player variable, which for now is still also 1. But now what we can do is after this click has happened and the player has taken their turn, we can say player is multiplied equaled -1. Well, this means that we take the player variable and then we multiply that variable by -1. That's why this multiplication and equals are in this order. If I play this again, I put a 1 here, so that's the same as last time. But this time, when I click down here, I now have a -1. And this is what's going to allow me to alternate between the players. So I get a 1 and then a -1, a 1 and a -1. But there is one potential bug here that might not be easy to spot. So if I click in this one and I put in a 1 here, what's going to happen if I click there again? Well, it just changes. So it's just going to go from one player to the other. Now, obviously, we don't want to be able to put different markers on the same spot. Once something is being clicked there, we don't want that to change. So what we want to do is add an additional check to this mouse click section up here. Here we work out our grid position, and then straight away we assign that grid data using the grid position. But what I want to do first is actually check, is there anything there? To do that, I'll simply say if grid data, so basically the same thing actually as what I'm doing here. So I'm just going to copy this instead of typing it out again. I'm going to take that exact same position, I'm going to look at what's already there, and I'll say if that is equal to 0, then it's fine. Then we can indent all of this and carry on like before. Try it again. So we'll go 1. If I click again, nothing happens. So we're not putting another 1 in there. Click again, nothing happens. I click somewhere else, then it registers and I get a -1. We've already got a lot of the functionality of the game working, and we haven't even got any graphics really. We've got this board, but there's no markers being placed down. However, we can see in the background that it's all working correctly. We're picking up player input and we're recording it in some kind of array. Now let's add these graphics. So we'll take the cross and the circle and we'll load them into our game. At the moment, they just exist in their own scenes here. But when we go into our main scene, they're not here. And the reason for that is because they haven't been linked. They haven't been instantiated. Our board node is here because it's a child of the main node, but the circle and the cross aren't. Well, we could do the same thing as we did before. We could go up here and instantiate, say, the circle, and that will pull it through. But now the problem is we already start off with a circle here. If I run the game, I now have a quarter circle appearing on the screen. I don't want them to appear until I've actually clicked. So what I actually want to do is only have them appear once a click is detected. So let's delete this from here, and instead we're going to instantiate this using code. We need to put little placeholders inside our script. So we go back into our script up here, into this main.gd, and right up at the top, after we extend node, we need to say @export, and then we create a new variable. So we actually export this variable out of our main node and our main scene. And we're going to give it a name, which is going to be circle_scene. And what kind of variable is it going to be? Well, we'll assign it just like we've done with the others, where it's an integer, an array. This is going to be a scene, or more specifically, a packed scene. If I save this now, and I go back into my main node up here, you'll notice that something new has appeared. So under our main.gd script, there's now this dropdown for circle scene. And that's because when we added this line here, it added it as an additional property of our node. So now we have a variable called circle scene, and we can assign any other scene into it. So we already know what we want. It's going to be this one here. We created it earlier. We just drag it across. And now that variable is going to be inside here. So we can instantiate our circle just through this code. We'll go down and create a new function for this. Underneath new game, I'll create a new function called create marker. This will take a few variables. One of them is going to be the player. We need to know which player it is, whether it's player 1 or player -1. Then we need to know the position where we're actually going to put this at. After that, we can use these variables. So we can add a note here to say create a marker node and add it as a child. First of all, we need to look at which player we're actually working with, whether it's a circle or a cross. Well, we're going to assign them to each individual player variable. So we'll say if player is equal to 1, so if it's player 1, then we want to create a circle. We'll say var circle is equal to, and then we call that scene that we've just created here. So this circle scene that we've imported, we can call that. We can say circle_scene dot instantiate. And this will do the same thing. This will do the same thing as what we did manually up here when we clicked this link, this chain link here. When we click that and we selected the board to bring it through, that will do the same thing. it's just going to be done through code rather than manually. Once it's instantiated though, we need to add it as a child of our main node, in the same way as board is. To do that, we just say add underscore child, and then we pass in circle variable. We still have another variable here, which is the position. So before we add this as a child node, we need to define its position on the screen. Say circle.position is equal to that position variable that we've just passed through. Now we can call this function. So we go back up here, and first of all, we check if there's anything in that grid data. So if there's nothing there, we populate it with a player variable. And then straight after that, we'll add a comment to say, place that player's marker. Then I can call that function by saying create marker. We'll pass in the player variable. That's the first argument that I needed. And the second argument was the position. So we take our grid position, and then we need to multiply it back out by our cell size. If I run this now and I start clicking, you can see that I'm putting down this little circle, but it's coming up in the wrong place. It's coming up in the cross rather than in the middle of the cell. And here we just add half a cell size. So we'll take vector to I, and we'll say cell size divided by 2. And then we do the same thing for the second one, cell size divided by 2. So that's going to offset the X and the Y coordinate by half a cell. Run it again, and now it's appearing perfectly in the center. You notice that the second click isn't showing anything, and that's because it's trying to put down crosses, or rather it's changing it to a 1, but I don't have any crosses to put down. So let's do that next. Let's load in the other scene, which is our crosses scene. We come back to the top, and I just copy this down because it's basically the same thing here, but now it's going to be in the cross scene. Then when we save this and we go back into our main node up here, the second variable appears. So we have our circle scene from before, but now we have a cross scene. So we just drag this cross scene into it, and now both of them are available inside this script. Now we can go down into this create marker function, and we just copy this stuff down. So currently we have if player equals 1, but we also have the alternative, which is player equals -1. So I could just do that, or instead, I can just add an else, because if it's not player 1, then it's got to be the other one. Then in here, I need to change all the references of circle to cross. And I'm actually just going to do this with a find and replace. I'll say circle, cross, and tick selection only, and it will only replace the ones in here. So it just saves a little bit of typing and does it a little bit quicker for me. And if we run this again, and I start clicking, so I put down a circle first, now I can put a cross down next to it, circle, cross, and I just keep alternating through them. I can't click on the same one, but as soon as I click on an empty space, it allows me to put down the next marker. But you notice these markers are all a little bit small, so we actually want to increase their size. This is where we go back into our scenes, so for the cross and the circle, and we can play around with all the different parameters. We change into a 2D view because those ones don't have a script. And in here, we can play around, we can move it, we can scale it, and we can do all of that within this right-hand panel. If we go into transform, it gives us a position and it gives us a scale. So I'm going to change the scale to 1.5, and it automatically scales it up by the same in the X and Y coordinates. Save that one, then we go to the circle and just do the same thing. So we scale this to 1.5 as well. If I run the game again, I can now get much better sized circles and crosses. Next, it's time to just fill out this little area on the right hand side. So I left this area blank before, and the intention was to have a little data information panel here. Well, let's fill that in. We don't need to create a separate scene for that. Instead, I'm just going to manually create it straight underneath my main node here. I'll press Ctrl A as a shortcut for adding a node. And the node that I want here is going to be a panel. So we'll just type panel, and it brings up this one here. I'll rename this to side panel. And straight away, you can see something has appeared here already. Now I can go into here and just start customizing it. The first thing I want to do is change its size. So I'll set it to 300 pixels wide and 600 tall. And then for positioning, there's different options, but you can use these anchor presets up here. So I want to position it on the right hand side of my panel. And I would just stick it directly over here. Next, I want to play around with the color. So we go down into my theme overrides here, go into styles, and I'll need to create a new one for it. So I just create a new style box flat. I don't have a texture or anything to use here or an image. So this allows me to just define an actual color. If I click it again, it brings up some more functions. So we'll change the background color here. So I'll play around, I'll just go 0, 170, 205. So this is what I used in the demo previously. So it gives us a kind of light blue color. I also want to add a little bit of a border between the panel and the game board here. And that's something you can control. So we can go into our border width and add a left-hand border of 5 pixels. And I'll just change the border color, set it to black. And now you can see I've got this little marker line here to separate the two areas. Next, I'd like to add some text here, which is going to say who the next player is. So again, we go back into our main node here, Control A, and this one is going to be a label. So we'll add in a little label here. And I always like to rename these because if I was to go in here and add a second label, you can see it just adds a number to it. So it'll just be label 2, 3, 4. And if you have a lot of nodes inside your game, it can become quite confusing to keep track of. So if you just quickly change the name as soon as you create it, then at least you know what's what. And this is going to be my player label. And again, it just appears in the top left. And what I want to do is add some text inside it that says next player. We'll just play around with the alignment options. So we'll just make everything center aligned. And then go into the transform section here just to move it around. So it's layout and then transform. We'll say it'll be 300 pixels wide, just like the size of that panel. And let's make it a bit taller. And let's move it over so it's 600 pixels across. And let's position it down a little bit. Now that font is very small. So we go into our theme overrides, font sizes, and then we can change the font here. So I'm going to set that to 46. And now I've got much bigger font. And then the last thing I want to add is a little panel in the middle here, which is going to show the marker of the next player. So we'll go again, add another node. It's going to be another panel. And panels are quite versatile. They have a lot of customization that you can add to them to make them look quite good. So with this one, again, we go into layout and then we look for the transform section here so we can set the size of it. So this one's going to be a little smaller. It'll be 200 by 200 and the position will be 650 by 200. And now just like before, I want to go into theme overrides, styles, and then create a new texture for it, which is going to, a new style box, which will be flat. Click on it again, and that brings up the menu here. We'll set this one to completely white. And I just want to add a little bit more detailing here. So we'll go into border width and we'll go 5 for all around border. And for the border color, I think I'll just leave it as it is. This kind of grayish color, it's quite good. But I also want to round the corners. So we go into corner radius and add 10, 10, 10, and 10. Just makes it look a little bit nicer. And then just for that final touch, we'll go into shadow and we'll add a 5 pixel shadow, which will offset by 5 pixels right and down. So it just kind of gives it a 3D effect and pops it off the panel underneath. So that's looking pretty good. And because this is always going to be present, it's always visible. That's why we can just add it as child nodes into our main class here, our main node. But now what we want to do is as soon as the game starts, if it's going to be the circle or cross going first, we want to show the next player's marker in here. So we go back into our script and right at the top, I need to create another variable. So underneath the player, I'll say var temp underscore marker. And we will use this variable to differentiate between the normal markers that we put onto the screen and this temporary marker that's going to be just in the right-hand panel. So I need to add another variable into this create marker function, which is going to be temp. And by default, I'll set that to false. So I'll assign a default value to it. Now, whenever this variable is passed, I can assign that temp marker variable in here. So after I've checked for example, if player is 1, then I know I'm creating a circle and I add it to my main class here. Well, I also want to create this temp marker as well. I'll say if temp, which just basically means if the temporary variable is true, then temp underscore marker is equal to the circle. So that same instance is going to be assigned to our temp marker instead. And I do the same down here, but I change it from circle to cross. By itself, this won't do anything, but when I call the create marker function and I pass this temp variable as true, it will notice to create one of these temp markers instead. So how do we create one? Well, first of all, before we even bother creating it, we need to know where to position it, because they're not going to be positioned on the grid like the rest of them. They'll be sitting inside this panel. So we need to know where this panel is on our game. And that means another variable. We go up to the top, underneath the temp marker, we'll say var player underscore panel underscore pause. And this is going to be another vector2, but it's restricted to integers. So it's vector2i. Then whenever we run our game, so this ready function is being called, we work out the board size, calculate the cell size. We do the exact same thing down here to take the coordinates. So we'll say get coordinates of small panel on right side of window. So we'll assign that variable player panel pause is equal to, we want to go into this player panel. Oh, I never renamed it. I gave that tip about renaming straight away and I didn't follow it. So that's going to be our player panel. And to access it, we use the shorthand like we did before with the $sign, and then it's the player panel. Then we run the get underscore position function on it. So this will assign its X and Y coordinates to this variable here. Now that we know where that position is, as soon as the game starts and we run this new game function, we can already create one of those temporary markers. So we go into our new game function here, and just at the bottom, after we've got the grid data out of the way, we can create, so add a comment to say create a marker to show starting player's turn. And this is going to be called, again, create marker. So we call the same function. It's going to be pretty much the same as before. So it's the player variable. But now for the position, we use that player panel pause. Again, we offset it by half a grid. So vector 2i and its cell size divided by 2 for the x offset and cell size divided by 2 for the y offset. But this time we add in this additional argument, which is going to be true. So this is what defines it as a temporary marker. And if we run this again, now you can see straight away we're getting this little circle. So that's telling us that that's what the next marker is going to be. So I can put down a circle. This now should change to a cross really. So that's the next thing we want to do. Now the point that will change at is inside this clicking section. So as soon as we have created our actual player's marker, so whatever we just put down onto the game board, then we update the player number. And at this point, now that we've updated the player number, we can add a section to say update the panel marker. So we call that same function. In fact, I'm just going to copy this from above because we call the same thing pretty much, but we just have to change a few of the variables. So it's the player like before, but we get rid of this section here because we position it at player panel pause and we offset it by half a cell. And just at the very end, it needs to be a value of true again, because this is going to be another temporary marker. If we run this again now, so we start off with a circle and now we change it to a cross. I say change, what it's actually doing is just drawing them on top of each other. So over time, we just get these knots and crosses drawn over one another. Obviously, we don't want that. So the next thing to do is between these moves, we want to clear what's here. We want to actually delete these ones. And to do that, before we actually even create the marker, we take our temp marker that's already there. So this is the previous one. So now we've put down our new one. We've changed the player number and we're just about to create a new temporary marker. So we need to delete the old one. For that, we just call q underscore free. And that will delete the previous one. Try this again. So we have a circle and now it deletes the old one and it draws a cross. So it kind of looks like it's changing, but actually it just removes the old one and then it puts down the new one. The next bit of functionality that I want to tackle is being able to check for a game win condition, because right now the game should end. We've got a win because we've got circles lined up in a row, but I can just continue playing. Well, before we get into all that, we need to define a couple of variables at the top. So I'm going to say var row underscore sum is an integer. I'll explain these as soon as we start using them, but it's easier to define them first, and then once we start setting it up, we'll explain what each one of these does. So we have a column sum, then we have diagonal 1 sum and diagonal 2 sum. Now we can go and create our new function. So we go all the way to the bottom and we'll create a new function which is going to be called check underscore win. So we'll put pass in here to allow us to run this. Now if I put down some markers just to show a game over condition, so here circles of 1. If we look at what this looks like in the grid here, we've got 1, 1 and 1. So if I simply add up the values inside that and I get 3, but that means that circle's 1, because that's the only way to get a number 3 is if you've got 1 in each of those cells. Likewise, if we get a -3, then it means that the crosses have 1. So if I put a cross in here, then this middle row will add up to -3. And that's what all those sum variables that we just defined were for. So I'll add a comment here to say add up the markers in each row, column, and diagonal. And we'll use a for loop here just to make the iteration a bit faster. So we'll say for I in line grid data. And then we can start calculating our sums. So first we'll do the rows. We'll say row sum is equal to, and then we need to just work through our indexes. So the grid data is here. To calculate each of the sums in the rows, we need to go through each of the individual indexes. So that's done by saying grid underscore data I0. So I, in this case, is going to start at the very first one, and then it's going to move on to the next one and the next one. 0 is going to be the very first index inside it. So we take this one, then we add it to this one, and add it to this one. So to do that, we'll just continue adding them up. Say plus I1 plus I2. That will give me the row, and then I can do the same thing for the columns. So I'll change this to column sum, but now I just swap these around. So it's now going to be 0 I, then it's going to be 1, then I, and it's going to be 2 and I. And lastly, I need to do the diagonals. So the first diagonal is diagonal 1 sum, which will go from 0, 0, top left corner, 1, 1, which is the middle, and 2, 2, which is the bottom right. And that's going to give us one diagonal, so the other diagonal is just the opposite one to that. So it's 0, 2, 1, 1, because they both go through the middle, and then 2, 0. Now that I have these sums, I can check if any of them match up to either 3 or -3. I comment here to say, check if either player has all of the markers in one line. I'll check if row sum is equal to 3, or column sum is equal to 3, or I should just copy and paste these, or diagonal sum 1. So we'll change the first one, diagonal 1 sum, and then I can just and change it to a 2. So if any of these are equal to 3, then that means that the circle has been placed in at least one of these rows. If that's the case, then we can define the winner as player 1. Now I need to do the same for the second player. So I just copy this down, but now I change this to an elif, so they can't both win. And I just change the 3's to -3's. And in this case, the winner is -1. And at the very end of this, we need to get this variable back out. So we'll say return winner. So that whenever this function is run, it's going to do all of these checks. And if anybody comes back as the winner, it will return that variable back to us. And at this point, you'll see that everything's lighting up red. And that's because I haven't defined this winner variable anywhere. But before we fix that, I think I've made a little mistake in how I've indented this. So I actually need to be doing these checks at every iteration of the for loop, not just at the end. So this indentation is not quite right. I need to indent it one more time so that all of this stuff here is handled inside the for loop. The only section that's not is this return variable at the end. So this is just indented inside our function, but the rest falls inside this for loop. So now I can go and actually define this variable winner. We go right to the top, underneath our player, we'll say var winner, and I'll define it as an integer. Then when we have our new game function down here, we'll say winner is equal to 0. Now we actually need to call that function. So we go back into the section here where we're checking for our clicks, and then we create a marker. So we put down the player's marker, and straight after that, before we even start changing the player number or anything like that, we want to check for that win. So we can run this function here. We can say check underscore win, but remember it actually returns a variable. That function returns the variable winner, and that means I can add an if statement to it, and I'll return that variable back and check for it. So I'll say if check win is anything other than 0, i.e. if it's a 1, then player 1 wins, and if it's a -1, then player 2 wins. That means I can say if it's not equal to 0, then that means that the game is finished. At this point, I don't have a game over menu, so we'll just say print game over, just to test it out. We run that, And let's just put a string of circles. Okay, it says game over. We can't keep playing, of course, so that's not quite working yet, but we are detecting a game over condition is being met. Before we get into the game over screen, we'll get rid of that and we'll just pause the game. So to do that, we say get_tree, add brackets and say paused is equal to true. And that alone should be enough to just stop the game. So we'll just do the same again. And now I can't put down any more markers. The game is completely paused. So at this point is where we would display our game over screen. The game over menu is going to be a standalone scene. So this isn't going to be something that we create as nodes in here. So we create a new scene by saying Control N, and that brings up our new scene here. I'll add in a node, and this one is going to be a different type of node from what we've used before. This is going to be a canvas layer. So I'll load in a canvas layer here, and what this effectively does is it means that this is going to be drawn on top of everything on our game screen. It's basically like the heads-up display. And it's typically what you would use for menus because they were always going to be drawn on top of everything else in your game. I'll rename this, I remember this time. So I'll call it game over menu, and we'll just save that straight away. Then let's move over to the 2D display just so we can start building it up. So by itself, it doesn't have anything, but I need to add in nodes to it. So we'll add a node, which is going to be a panel. And we'll change this to our game over panel. Now let's customize it. So we'll go into our layout here, change the anchor of it, put it in the middle of the screen, play around with some of the positions. So we'll define a width 400, height of 250, and I'll actually offset it from what I had there. So we'll say 100 and 175. Then we just want to go down and style it. So theme overrides, styles, and we'll create a new style box flat. Click it again to allow us to select it. And then I'll play around with the colors. So I think this is again what I set previously. So 61, 78. So that's the color that I had in my demo. I'll add a border to it. So we'll go for an all round border. Give it a color, kind of go for a yellowy color. And again, this is just what I did previously. 491, like this, I think. There we go. So now we've got this yellow border all around, and then we'll just give it a corner radius. I just think it looks better when it's rounded off like this. Now let's stick a label onto this. So we'll add another node, and this is going to be our label. We'll rename that, and this is our result label. So this will just display the outcome of the result. We'll just say for now, player 1 wins. We will actually use the player variable in the code to update this manually, or rather automatically, but for now, just as a placeholder, we'll put something in. And we'll update our alignment to be central on both. And then we'll just go into our layout, so just kind of as before, and this is what you would use just to position everything in your scene before. So we'll go into our size, and I'll go 267, 58, 166.5, 200. So you can play around with all of these, but I've already made this game, so I kind of know where I'm going to position everything. And lastly, I want to increase the font size because it is tiny, and we'll go with 40. So zoom in a little bit, but that's looking better. And now I need to add a button underneath, and that's going to be my restart button. So we go in here, add another node, and this is going to be a button node. Change the name of that one, restart. And by this point, you should be getting a hang of this workflow. It's kind of just adding on nodes, changing the names, and then playing around with the properties. So again, this one starts off on the top left, so we need to play around with its position. We'll add a text here, so the button is going to say play again. Then we'll go down to layout, and we'll move it around. Oops, wrong one. So on the transform, we'll make it 250 by 63, 175, and 300 for the Y coordinate. So it sits nicely underneath and inside this panel. Then we just want to go into our font overrides, or rather our theme overrides. We'll say font size, set that to 40. And then within styles, just the same way as with the others, you can customize it, but because this button has different properties, it's got a hover, a normal, and a press state, you can manually override these for each one. So we can create, for example, a flat box here, change that color to green. Border. So I guess you can play around with all these things. I'm not going to go into too much on it. We just want to get it looking pretty decent here. But then once all that's done and you're happy with how it looks, we go back into our main scene and we need to instantiate this over here. So just like we did before, we click this little link and we bring over this game over menu. And you can see straight away, there it is. It appears on here. If I press F6 to run this, it's here straight away. We don't actually want it. We want to be able to click and be able to play the game, but the panel is sitting there in the way. When the game starts, we don't want to show this panel. We want to be able to hide it. So we go into the script for our main file and into our new game function here. So just after we create this marker, we'll use this shorthand, the $sign, to access our game over menu. And we'll just say hide. So now if we run this again, the menu is gone. So we can play the game as normal. But now we want that menu to come up as soon as the game is finished. And that's handled inside here. So we first of all pause the game. And then as soon as we've paused it, again, we access this game over menu. And now it's show instead of hide. So if we run this again and we just go circle, 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 now the menu comes up. We can't click on it, nothing happens yet, but that's the next bit. We can now link this button to a new game function so that we can reset everything and go again. Now for that, we go back over to our scene for the game over menu. And right now it doesn't have a script. So that's why when I change tabs, we still see the same script as before. Because over here, it's showing us our main game script. So we click on here and we add a new script for it. Keep everything as it is and just click create. So now this will extend the canvas layer node, because remember that's what this was before I changed the name of it. And then it gives us these two functions. We don't actually need either of them, so we'll just delete them both. What we do need here is a signal. So this restart button, whenever it's clicked, we need it to actually register that it's clicked. It needs to tell the game that that's happened. And that happens up here. If you go into node, you can see all of the different things and all the different functions that the button has. The one we're looking for is pressed. So as soon as the button is pressed, we want it to do something. If we double click this, it will create a signal. So it will allow us to connect that click signal into our code. So we just keep everything the same, select this parent node game over menu and click connect. And you notice it creates a function by itself. The function comes with this little sign here, which means basically that we've got a connection. We've got a signal that's connected from the button into our game over menu scene. And the signal is triggered when the button is pressed. So now we can use this functionality. But the problem is that this functionality here, the signal, happens inside this scene, but we actually need it inside our main scene. So how do we link the two together? Well, we need to take it one step further. We need to emit the signal. So up here, we'll say signal restart. A restart is just a variable, so you can call it whatever you want. But signal means that it's going to be emitting this. And now within our function, we can get rid of this pass statement and we can say restart, which is that variable name that I just made up, dot emit. And what this basically says is that as soon as that restart button has been pressed, we take this variable and we emit it out of this scene. Now it might be difficult to picture what's going on there, but now if we go back into our main scene and click on this game over, you can now see over here in the notes section and signals, the game over menu now has its own signal, which is this restart. This restart is what we're emitting from here. That's the name of this variable. So we can now use this in the same way. We can take this variable, double click it, and now we can connect this into our main code. If we click connect, the same thing happens. We create a new function here, but now it's not looking for a button click. That's happening in the other scene. It's now looking for this restart variable being emitted. If we click on this here now, it's saying that the source is the game over menu, the signal is the restart variable, and the target is our main scene here. So when that button is pressed, what do we actually want to happen? Well, now it might make sense why I created this new game function rather than putting all of these variables inside the ready function. The ready function will run only when the game first launches, but the new game function can be run anytime, such as when we restart the game. So if I put new game in here, now our new game function does have a section inside it which gets rid of the game over menu. So if I was to run this now, and I was to continue, game over, and I click play again, at this point I should be emitting that signal. But this menu is still here, it's not being hidden. And that's because when the game pauses, everything pauses with it. Now I don't want the game over panel to pause, I want that to stay. So we go into the inspector, and there's a section here under the node called process. We expand that out, and there's a mode here. I won't go too far into this, but basically this is what's going to allow me to choose when this runs. So for all the others, I want them to pause as normal. So when the game's paused, everything stops. But the menu shouldn't disappear when the game is paused. So I select the when paused option, which means that whenever I pause the game, this menu can now be used. If we run this again and we end the game, I click play again, the menu disappears. The game, however, hasn't reset. So that's the next stage. What we need to do inside this new game function now is actually use it not only as a way of setting up the game initially, but actually of resetting the game. So we want to basically reset all of the variables inside here now. There are some variables such as the sums, like row sum, column sum, and so on. We want to reset them here. So we'll say they are all equal to 0. And I'll just copy this down, I'll change this to column, and then this one will be our diagonal 1. And I can copy this again and just change it to diagonal 2. So that resets all of those variables, but the markers are still on the screen. So when we ran this and we restarted, those markers didn't disappear. In fact, we got a new circle here on top of the existing one. So we want a way of clearing all of those markers. And the easiest way to do that is to bunch them all together. So if we keep track of them and stick them all inside one big group, then it means that we can just clear whatever's in that group. It's just like one big bucket for all of these markers. And that's done inside their own scenes. So we go into our cross scene, which we haven't really done much with, and we go into node, select the sprite 2D node here, and then you can see this groups button. So we click groups and then we just add a new one. So this is going to be called crosses. I'll add that and I do the same thing with my circle. Click there, go into groups and create the circles group. Now inside my main file, if I go back over to my script, I can empty both of those groups whenever I make a new game. So down here, I'll add a comment to say clear existing markers. So I'll go into my overall root, which is my main scene and the main node, by saying get tree.call_group. And then the group name, well, I had two groups I just created. So one of them was circles. And then I passed the function to them, which is going to be queue_free. Remember, I used this earlier to delete the marker. So I can use this on the group as well to delete the entire group. Now I pass it again, but this time I change it to crosses. The last thing would be to unpause the game, of course. So at this point, we need to go get_tree.paused is equal to false. So let's just see if that worked. We'll bring up the game over menu, click play again, and everything's cleared. And I can start again and just continue the game from before. So that takes care of our new game condition, as well as checking for a win and a lose. But what it doesn't check for is a tie. At this point, the game hasn't stopped. We can't put down any more markers, but we can't reset either. So we need to be able to look out for a tie. And the easiest way to do that is just to count how many moves have been played. So right at the top, after the player, we'll say var moves, and we'll say that that is an integer. Then when we create our new game inside this new game function, so just before the winner is defined, we'll say that moves is equal to 0. And then every time we click to take a move, we just increase that variable by 1. So here we'll say that moves is increased by 1. And now we can add a second condition to this check win section. So just in line with this indentation, underneath that I will add a comment to say check if the board has been filled. So this is going to be an elif statement, because we're saying, first of all, if we've checked for the board and one of the players has won, then we run this code. But if nobody has won, then we can say elif moves is equal to 9. So nobody has won yet, but we've now played 9 moves. Well, that still means that the game is over. So we want to bring this up again. So we want to pause the game and we want to show our game over menu. The very last thing then is to actually update that data. So whenever we finish the game, it just says player 1 wins. But we know that that's just a text from before, which we had in here by default. So inside this label, we typed player 1 wins. We want that to be changed depending on the actual outcome of the game. So after we pause the game and we show our game over menu, we'll say if winner is equal to 1, so that's player 1 has won. Then we go into our game over menu node, just like before. And then from there, we need to go down a level. So the game over menu has this result label inside it. To access that one, we say .get_node. This is an alternative to using this $sign shorthand. and then we type the name of the node, which is result label. Then we say dot text is equal to, and we can change this to whatever we want. Well, in this case, it doesn't actually need to change from the default, but it says player 1 wins. Otherwise, so elif winner is equal to -1, then we do the same thing, but now we change it to player 2 wins. And lastly, we need to paste this again for our tie break scenario. So if nobody has won, then we change this text to say it's a tie. So if we test this again, and this time I'll try and let the crosses win. So I'll put a circle down here and a cross, and now player 2 wins. And that's it. And that's how you create tic-tac-toe using Godot. So if you made it all the way through that, then congratulations. And I hope this helps you understand Godot a little bit better. Thanks for watching.